Hi, Assalamualaikum. So today we learn about superposition theorem. So let's check the steps involved in superposition. So the first step is you will need to turn on one power source and turn off the others. So how to turn off the supply? For voltage source, we replace the voltage source with short circuit, and then for current source we replace it with open circuit. The second step is we draw current flow and then solve the current at each resistor. So these two steps we need to repeat for the another power source. Okay, so after we get all the current flow for both steps, we do the last step, which is superimpose. Okay, so we look at this example. There is two supply V1 and V2. Okay, so we want to calculate the current flow at R1, R2 and R3 using superposition theorem. So step 1, we need to turn on V1 and then turn off the V2. It become like this. So V1 stay there, and V2 we replace with short circuit. So the next step is we have to calculate, we have to draw the current flow. So we draw here, sorry, this is I total. Okay, this is I1, this is I2. So after we finish draw the current flow, so we need to calculate the R total. Okay, so this is how to calculate R total. R3 and R4 in series, and then parallel with R2, and then series with R1. So we put into the calculator R3 and R4 in series, kita tambah, and then darab silang dengan R2 which is in parallel, and then plus 300 which is R1. So we get the answer R total 554.545 ohm. And then we can calculate I total, V1 the supply over R total. So 10 over 554.545, we get the answer 18.033. So we get the I total here. So the next step, we have to calculate I1 and I2. So if you want to get I1, so this is a step. So using CDR, okay, this is using CDR. Okay, okay. So using CDR, okay, R1 over R2, R3 plus R4, okay, times I total. So we put the value and then get into calculator, we get the answer 6.557 milliampere. This is the value for I1. So to get I2, so I total minus I1, so you get 11.476 milliampere. So we finish for the step 1. Okay, and then we go to step 2. The step 2, we turn on V2 and then we turn off V1. So the circuit will be like this. Okay, so V1 replaced with short circuit. So we repeat the step by drawing the current flow. Okay, so we draw here. Okay, this is IA. Okay, and then this is IB, and then this is IC. Okay, so first we have to calculate the R total again. So R total here is different from previous because the voltage is at the middle. So R3 and R4 in series, okay, and then parallel with R1, and then series with R2. So we get into calculator, and then we get the answer 610 ohm. So IA, which is I total in this circuit, we get by V2 over R total. So we get the answer 8.175 milliampere. After we get IA, and we need to find IB and IC. So to get this, okay, we use CDR, current divider rule, to calculate IC R1 over R1 plus R34. R34 is series, 500 and 200, so it becomes 700 here. So 300 over 300 plus 700 times 8.197 milli, we get 2.459 milliampere. This is the value for IC. To get IB, okay, we minus IA minus IC, so to get the answer 5.738 milliampere. Okay, so we finish for second step. So we go to last step, which is we need to do superimpose. Superimpose, we just draw the original circuit, and then we need to draw, okay, the current flow from step 1 and step 2. So, okay, I total here, this is I1, and then this is I2. In step 2, we have here, IA, okay, IA, this is IB, and this one is IC. Okay, we got all this thing from step 1 and step 2. So here we only need to calculate current at R1, which is I total minus IB, because it is in opposite direction. So I total minus IB, we get 12.295 milliampere. So IR2 is here 400 ohm ni. Okay, I2 minus the IA, so we got 3.279 milliampere. And then IR4 is same with IR3. Okay, so to get IR3, I1 plus IC, because in the same direction, so we get the answer 9.016 milliampere. So we have answer all the question, IR1, IR2 and IR3. Okay, we have finished. Well done. Thank you very much for your attention. Bye.